Recording. All right, good night, good evening. Where it is Tuesday, April 26th. We're going to get started on session 2 of the Bootcamp Prep. We're going to do a quick review of functions, and then we're going to move into control flow and iteration. So that'll be talking about loops, built-in methods, which again, we did start to discuss yesterday, problem solving, and then we'll do a REPL intro, which again, you've seen me using the REPL, talk about some clean code, and then that'll be it for talking. And then we're going to get into some of the basic challenges at the start of the list there. All right. So yesterday we closed out with functions, and almost all the code you write in software is going to be in one function or another. It's just an easy way for you to keep your code organized and make it reusable, and basically in different parts of your application. So if you have a piece of software that you're working on and it needs to do the same thing in 4 or 5 different places, instead of writing that code over and over again 4 or 5 times in each place, you're just going to write a function that you can call wherever you need it in that code. And why that becomes important is that if right now we write small challenges, we tend to write them and then we're done with them and we move on. But when we write actual in production practical software, we hope that that software is around for years, if not decades. And so when we write a function today, it may not be exactly what we need 6 months or a year, or even a week from now. And instead of having to go in and change it in 4 or 5 places each time, or if you forget, then it works in 4 places and it's broken in the 5th place. When we just change it that one time for future updates in the function, we ensure that it's being used uniformly throughout the application. And again, I give like a small instance of like maybe 4 or 5 times, but in the software that I'm writing, there's some commonly used methods that we have that may be used 100, 150 times throughout the application. And now if we had to go and change every time that needed to be nudged a little bit, or we had to tweak it, and then someone had to go through the code base and make that same nudge or tweak 100 or 150 times, we wouldn't get a whole lot done. We'd also be very resistant to making small changes, which means that the software over time would start to kind of get clunky. So functions use case is reusable blocks of code that perform a specific set of instructions that you define or that are built into the language. So again, we're going to talk a little bit later about built-ins. This function at the bottom is one that we would create ourselves. And we kind of talked yesterday about like the difference between console logging and returning. So functions can be defined to accept 0 or more inputs, which we call parameters, and in most cases output a value or return a value. To declare a new function, we use the function keyword followed by the name of the function, which is the old way of doing it. When a return statement is encountered, the function exits immediately, returning the return value. That is something that I did not talk about yesterday. So if we just write a basic function here. So if I say const addition, we say A and B, right? And then we're going to return A plus B. And so remember, we're returning. So if I just do addition 3 and 4, I would expect that this would return 7. And it is, but we're not seeing it over here in the console. We actually have to send something to the console by logging it. So the best way to do it is just to console.log your actual function call, not to put a console.log inside your function. You may have to do it when we start getting into debugging or figuring out what our function's doing, and it's maybe not doing exactly what we expect it to. But when we want to see the answer, like the final answer from our function in the console, we just want to take the function call and wrap it in console.log. I know, and this is like the #1 question we get in the intro to coding, is there is an older video from Tom Preet, one of the full-time instructors, doing some of these challenges in Replit. And like 2 or 3 years ago, you did not have to console.log to see your return statement in the console. It just did it for you automatically. And so when you watch the videos and he does it, he would just put like addition 3 and 4 and it shows up in the console. And if you do it today, it does not, and it throws everyone for a loop. So, but now when I send it over there, I see my 7, right? And so another thing we didn't really do was talk about how this is reusable, right? So if I want to say const add 1 is equal to 3 plus 4, right? And I console.log this, right? I get my 7, but what if I want to know what 5 plus 8 is, right? I can redeclare this variable, but if I need this, now I have to write const add 2 equals 5 plus 8, right? And so then I have to console.log that separately, right? So that's 13. These are not reusable. This is just one value, and we're making it permanent. We're making it static for the life of the program. And so what a function allows us to do is actually reuse this addition. So I can come in here and I can say 3 and 4. I can come down here, I can do it again. I can do 5 and 8. And so every time I feed in 2 numbers into my function addition, I know that it's going to add those 2 numbers together, right? And so it becomes reusable. So I can use it in different parts. Like if I were all the stuff we do is typically an index, but if I were to start like adding additional files, I could start passing it around between the files. And it's just a way to keep everything organized. And also, so like I don't need to have a bunch of variables in here that are just different combinations of numbers that I need to add together. I can just move the addition function around and use it wherever I need it to calculate the sum of 2 numbers. And so the other thing we didn't talk about yesterday is this: as soon as you see return, whatever is on this line is the last line of code that this function will do, right? So if I say console.log before the return, oops, spelling error. When I say console.log after the return, all right, before the return, saying it twice because I'm calling the function down here twice, but basically whatever happens after the return never gets executed. This is the last line of code that will run inside a function. Replit isn't that nice about it. If we were to, and I think I popped this up the other day, but like if I were to take something in a real IDE, so if I come in here, and I look at, again, so my FizzBuzz, and I've got my return down here. If I put my return up here, see what happened to all of this code down here? It got grayed out. And what it's telling me is that this code is unreachable code detected. Nothing ever happens after a return. So and once you get into Code Platoon or most boot camps, you will no longer be using Replit. This is just a easy way for us to get you the very basics of coding without you having to download another program, set it up, do all the extensions, do all the troubleshooting, which is basically your first day of Code Platoon. I mean, for anyone that was in and remembers like their first day of boot camp, it's where you get all your gear thrown at you and you stand there not knowing what's going on. That's pretty much what the first day of Code Platoon is. It's just they're basically chucking software at you. And So Replit is not as powerful as kind of like what our day-to-day tools are, but it's a good stepping stone. So it helps you with the color syntax, because the other thing we can do is, I'm not on a Windows machine, I'm on a Mac, but you can write code in just like the basic text editor on Windows, right? Like you can write code with without all the syntax highlighting and basically all this pop-up stuff. And as long as you put a .js at the end of the file, it'll get read just like a JS file written in Replit or a JS file written on VS Code. It's just a lot harder. And so there's a whole suite of tools out there that are designed to make our jobs as software developers easier. All right. So let's see here. What are functions? So again, we've got, this is the old style of writing it. So function, the name of our function, any parameters we want to feed into it. And so I guess I should point this out as well. A and B right here is just an example. And these aren't necessarily great examples. One letter parameter names, one letter variable names, like I talked about yesterday, like let X equal. And if I put 32 here, it looks great. But if I go down past where you can't see let X on the screen equal 32 anymore, and I ask you what X is, it's impossible to tell me what X is unless that you saw this first line of code. It's the same thing for right here. What would be much more practical is that A would be num1 and B would be num2. So now if I say, because if I, and the same thing, I can say, right, and I can say cheese sandwich, and I can run cheese sandwich AB, and I still get 7, right? But if I come down here and do this to you, no one can really tell me what the heck cheese sandwich is going to do with 3 and 4, right? And so it just makes it harder. So what we want to do is give everything good names. So what would be much more appropriate would be something like addition, num1, num2. And now if I run this, it's going to blow up because I haven't changed it down here yet, right? A and B are now defined, or I'm sorry, well, it's going to hit cheese sandwich first. All right. Oop, spelling error. So A is not defined. So if I change A to num1, now B is not defined, can change that to num2. And now we're working again. But notice how addition num1, num2 did the exact same thing as cheese sandwich AB. Those are just names. Names don't have any specific power as long as everything lines up. Names are for humans. The computer doesn't care if it's cheese sandwich or it's addition. It's only going to do exactly what you tell it to do. With, say, like, I mean, I could name this banana and orange, right? And so, and it's still going to add banana and orange together. The computer isn't going to look at it and be like, that's stupid. You can't add a banana and an orange. It's just going to say, okay, whatever these two things are, I'm going to try and add them together, and either it's going to work or it's going to blow up and I'm going to yell at you, but it's not my fault because I'm the computer and I will only do exactly what you tell me to do. So again, the 3 formats. So I just wrote addition in this format. Oops, sorry, let me just get this out of the way for right now. All right, so this is the ES6, same thing. I can do function old edition, right, and say num1, num2, and if I change this down here to old edition, I got a spelling error somewhere. That's it. Yeah, so the old way, because we see function and basically because it says function, you say, oh boy, it's a function, I know it. It can seem more intuitive while we're learning. But this is also, I mean, basically denotes that you're dealing with a function. And you will see this in, what am I doing wrong here with this one? Function name, friends that turn, do not know why it doesn't like that. Did I spell something wrong? All right, I'm not sure with that one why it won't run that. I'll poke at it here in a minute. But so this is the more common way, the more modern way that you'll see it. So I can flip back and forth between the two for you. I'm comfortable writing it either way, but because this is easier to understand, like if you see function, you know you're dealing with a function. This is the one that you'll want to start wrapping your brain around.
Whenever you call a function with maybe some more complex numbers, when you have several numbers after a decimal, is there a way to return? Is there a way to define that final number? A way to limit it to like maybe 2 decimal places if you're dealing with money or anything like that? Is there a way to, when you want to return a number, rather than it give you a very long, complex remainder, can you limit it to 2 spots?
Yes. So yes and no, and that's actually like a tricky topic. Computers are horrible at rounding numbers, mainly because they go out so many decimal places. So with a number with multiple or something to the right of the decimal place is called a float, and there are ways that you can visually display it. So there's a way to truncate a number basically at 2 decimal places and round it. But what happens is that's when the data is visually presented to you, but behind the scenes, it's still going off that big, long floating, like big, long decimal. And so when you start adding up like large calculations where maybe you're adding a million different numbers with like that floating decimal, and you only see the 2, but it's going all the way out to like the 15th place or 16th place, it'll end up with a slightly different number. Like eventually it's going to start making a difference on the left side of the decimal place. Now but for like simple calculations, there is a way to lock your float and specify, like, I want it to be 1 decimal place, no decimal place, 4 decimal place, whatever you want. A common easy way of dealing with money is to multiply by everything by 100. So you get rid of the decimal place, you do all of your calculations, then you divide by 100. And also, if like, let's say if I were to be writing like an actual application, say like if I worked at a bank or a fintech firm or something like that, I would most likely implement a third-party package where they've already ironed all of that out for me, and just put that into place and use someone else's pre-coded solution for that, because there is actually quite a bit of complexity around dealing with money in computers. And I see a hand up. And sorry if I'm not pronouncing the name right. Is it Ever?
Sorry about that. Yeah, I typed it in the chat, but I was just curious, with functions, is there a limitation to the amount of characters, like when you're naming a function?
Not really, not practically. I mean, I mean, I guess you could write a function name long enough to run your computer out of memory. I mean, we can also. 254 characters. So that would be, and that's quite a bit. I mean, that's like a double tweet almost basically for a function name. And you will see long function names, but I don't think I've ever seen one that's ever ran against the limit, because what happens is we don't quite often, and we'll talk about this, is with higher order functions, is that functions will call other functions. And so if you start ending up with a function that has a really long name, or like 5 different functions that have a really long name, and they all interact with each other, is like you end up with this giant word salad of code that makes it more difficult to read through. And so and this is kind of where I go back to, I said it yesterday, naming things is hard. We're always trying to strike the balance between succinctness, but also descriptiveness. All right. So are we okay with functions? Is there any other questions I can answer on that? And we're going to be talking about functions for the next 3 weeks. Like, those don't go away. It's going to be one of the big primary building blocks that we discuss over and over again. All right, so let's go ahead and move on to control flow then. So control flow is conditional logic. This is how we start getting into branching logic that we use to tell a computer to do different things when different things or when different occurrences happen. So when you want to control how a computer goes through your program, use control flow. This evaluates either true or false, which are Boolean values, and allows us to select different outcomes depending on user input or the result of a computation. So an if statement is the most basic control logic. So we can say if A is strictly equal to B, do something. An if else statement, which is just 2 conditions. So basically, if A is equal to B, then do this, else do this, right? And then we also have an else if statement, which allows us to give additional guidance. And so once you go past like a else if, like basically an if else, we'll start to talk about switch or case statements. But for right now, we'll look at these 3 different ones. So let's go ahead and pull this up. All right, so I can say if 3 is triple equal to 3, return hello. Oh, what did I do wrong here? Sorry, I've been working in Ruby all day today. That should have worked.
Are you not supposed to consult something for us to see?
Yes, thank you. And that was a prime example of saving your instructor, because I was probably going to look at that for 10 minutes before I would have came to the point where I needed to console.log that. I apologize. Who said that? I didn't see it.
Yazid.
Thank you, sir.
You're welcome.
All right. So console.log hello. All right. So now if I were to say if 3 is equal to 4, right, that's where we have an issue. And so, and again, we kind of talked about this yesterday, right? The difference between equal and strictly equal, right? So nothing happens, but if I do this, this is true. And so we can start to imagine some of the different scenarios where this becomes a problem. All right. So now we can start doing things like equal, else, right? So if we run this, we've got equal. If I turn this back to strictly equal, right, not equal. Now, there are additional things that we can do here. I can also do this. So what should this, am I going to return equal or not equal?
Equal.
Okay, and why? What am I doing here?
It's
With
the
the
bang.
bang.
Just
Your
checking
string
the
is
different.
not, yeah, sorry.
Right. So the string is not strictly equal to this, and this is asking for the opposite, right? So this would return not equal. This would return equal. Right. And that, I'm sorry, that's a little confusing when I do that. So I can, let's change this to true and false. Right. So this is a true statement. This is a true statement. This resolves to false. Right. And there's also, I mean, what happens in if statements. So like, it doesn't necessarily just have to be a, like comparing like a string or just two numbers. I can use a function in here. Right. And so if I change this to 8, we've got true. And the reason being is because remember, when we return out of a function at the end of the day, we see all of this, but the computer sees this. Right. All of this over here is resolving to this. So same thing here. The computer looks at it, goes, okay, addition, comes into addition. Okay, I've got parameter 1 is 3, parameter 2 is 5. Let's add num1 and num2 together. That gives me 8. This resolves to 8. Is 8 strictly equal to 8? Yes, it is. I get my true value. All right, and same thing. I could write another method that says subtraction, right? And say subtraction. Let's do 11 and 3. Right, so 11 minus 3 is 8, 3 plus 5 is 8, right? That's true, right? If I say this is 12, so now it's 8 and 9, right? That's false. Now, before an else statement, I can, if we look over here, we've got this third option, which is else if. And I can say, and give a second set of basically a second conditional operator that I'm looking for to check again. So I could say if addition I'll just do if 9 is greater than 5. Oops. Sorry. Then we'll go ahead and say console log larger. And so what also is going to happen here, and I'm sorry, we've arrived at in maybe a slightly confusing way, but when we console.log, remember, we keep going. So what I would expect to have happen with this is we're going to come in and say, let's run it, right? So we get to larger. And so if I say that this is 11, right, we get to true. So we hit the first one and we stop, right? And so even though this is true, we'll always stop at the first one. Now, you will run into challenges where the order of how you basically put your conditional logic will have an impact on your ability to solve the challenge. There'll be ways that if you hit certain true conditions before other true conditions, you won't come up with the right answer. So paying attention to what order you put these in is important. Is there any questions before I move on to iteration with this? And again, if statements, we're going to talk about them over and over again over the course of the 3 weeks.
I did have a question. So before you call a function, does it need, like, do you have to have that function basically defined before you call it? Say you moved that subtraction function to like line 24. Would that if statement actually run?
Cannot access subtraction before it's initialized.
Cool.
All right. So, and that's a great question. And what's happening there is basically, remember, computers start at the top and they read from top to bottom without fail. So what's happening is the computers, like I hit run, computer comes into the file, it says, okay, and instantiate a variable called addition. What is addition? Okay, well, it looks like it's going to be a function. These are the parameters. This is what addition does. Okay, nothing happens, like nothing gets put out to the console, even though we've got the console.log here. This is basically ready to go, but nothing happens until we call the function, right? And then when we call the function, the computer says, okay, read this, come up here, run the code. This resolves to 8. Okay, subtraction, call it, and it's looking at what was up here, and it says, okay, no one ever told me what subtraction was, right? So you have to have it basically above the first time that you call it. And notice how, so reading the errors is a huge part of learning software development. Notice how, I mean, some errors aren't that great. Some errors can be misleading, but at the level that we're building at right now, these will almost always tell you exactly what's going on, right? Cannot access subtraction before initialization. So and if I do this, right, now, because I just deleted it and I didn't put it back up here, subtraction is not defined, right? So like we're getting told exactly what's going on, like what's going wrong here. And when I went through and did addition and I was changing it from A to B to num1 to num2 and cheese sandwich, notice how like I was hitting the button, I was getting an error message. The error message was saying like, hey, cheese sandwich isn't defined because I still left it there down in my function call. So I fixed it down there. I hit it again. It says, well, you know what? A is not defined. Okay, well, change A to num1. Hit it again. Well, you know what? B is not defined either. Great. Change B to num2. And I was using my error messages to help guide me on what to fix next on my code. Still 2 hands up, questions, or I know they don't go down automatically after you talk, so.
I had my hand up. Just had a question about the conditional statements, you had mentioned that it's super important that they're in the order that they need to be. Is that just because the computer's going to like read down until it finds one that matches whatever you're asking it to do, and then it kind of stops from there?
Right. So let's look at something like this. So let's let shoe size equal 13, right? And we say if shoe size is greater than 5, console.log medium socks, right? And we say else if shoe size greater than 9, console.log large socks. And then we say else if shoe size is greater than 12, console.log extra large socks. Else we don't have, oops. All right, so looking at this, what size, so if I just say, hey, I've got a shoe size 13, what size socks do I need?
It's going to be extra large because that's the last one.
Right.
You need extra large, but it's gonna say
Gonna say medium socks.
Right, because I hit the very first true condition and the machine says, okay, you get medium socks. Right, and so that is not a desired outcome. And now the same thing, so what we could do is basically in an instance like this, what we would want to do is say 12, 9, and 5, right? And so now if we say XL, L, the medium, all right, now I get my XL socks. But if I'm only a size 11, right, I skip, so I come in, is 11 greater than 12? That's false. So I do not execute what's in here. I come down here, else if is 11 greater than 9? Yes, it is. Okay, boom, we're done. And so the order that we put these in can have an impact on the outcome of what we're trying to do. Does that help illustrate it a little bit better?
Yes, it does. Thank you.
Cool. Any other questions? Anyone else? All right. And so and this was, I mean, again, like we did some strictly equal, greater than, you can do less than, equal to. Basically anything, and same thing. I can also, and this isn't something you ever want to do, but you can basically just hard code things, right? So it doesn't matter like what I put in, like I put true in that first condition, because what's happening, and we talk about this, is like when we write this function, right, addition 3 plus 5 resolves to addition equals 8. What's happening is this is going to resolve to true, oops, is either going to resolve to true or false. And if it's true, we come in here. If it's false, we skip over it and go to the next condition. And if there are no other conditions, like if we just have a basic if statement, right, where we only want something to happen when a condition is true, otherwise nothing happens. I mean, it's very common just to see if statements, And those are typically can be referred to as guard clauses, where we just put something in there that happens only if one condition happens, and basically that's it, and it happens. If not, we move on and we do something else completely different in the program. All right. So yes.
When you first typed that, you had 5, 9, 12. Would greater than 5 but less than 9 in the same line, would that constrict it, or you can't do like greater than 5 and then less than?
So you
another
can, but what it is, and it's probably not the way you're thinking because it's not the standard math way. So what we can say is, so we can do something like this, right? So if, and because what you're probably thinking is if we do like if 11 and it's less than 11 and greater than 5, right? Then we say right, or else right. And so when I try and run this, what's going to happen is I should blow up. Let me just comment this out. Let me comment this out as well. All right, so I run this. Okay, well, it didn't blow up. That's weird. But it also didn't give me the right answer. Well, actually, it did give me the right answer. Well, it's still giving me you are not a medium. So basically, this is arrowing out, and it's just defaulting to my false. And what actually needs to happen here is it needs to, remember how we talked yesterday about and or. So if we say if shoe size is less than 11 and shoe size is greater than 5, then you are a medium. So now if this is true and this is true, this is true. But if one of these is false, will be false. So if I run this, you are a medium, right? And so if I change myself to a 12, right, you are not a medium because this is false. And the same thing, if I change myself to a 4 or a 3, you are not a medium, right? And now what can happen here is if I change this to or, right, you are a medium, even though I'm not a medium, right? 3 is a small. It's because this is true. 3 is less than 11. And so we never even get to this. We don't care that this is false. And so this is where using the correct and or operators is important in your conditional logic. And I mean, you can keep going and going and going. But what happens is like, as you start to add more and more of these, they can get more complicated and it becomes harder to figure out exactly what's being calculated in there. Does this answer your question?
It does. So would you prefer using the top method where you just start with the biggest and work your way down to the smallest, or are both ways right?
Either way is right.
I guess what would you do?
Yeah, and it just really, it comes down to if you start to get to the point where like maybe you've got like 3 and statements in here, that maybe you start to look at breaking apart. But also, I mean, we're just doing shoe size, right? So like there's going to be situations where like this is giving us a range, but let's say that you're only a medium if your shoe size and your shirt size is equal to M, and but pant size equal M, right? And now we can say basically that, and pant size is M, and shirt size is M. Right, and so now all of these conditions have to be met. Oops, let's change. So because this one was not met, right, then we fail. But so if I change this to a 7, right, all of these come back. If I change this, my shirt size to a large, right, you're not a medium. And so what we can also do is we could say that if your shoe size is between this and this, or your pant size is medium, or your shirt size is medium, you're medium. Right, so you are a medium, even though my pant size is large, right? So I only have to have one medium thing to be a medium. So I could do shirt size is large, pant size is small, right? You're not a medium. But if I change my pant size back to medium, right, you are medium. So, and this is what we use to tell computers what to do, right? So, and Charles comes in and puts all his clothing sizes in. Here's the sizes that you recommend to him based on the numbers that he put in. Here are your customized recommendations for our product in the correct sizes, right? And so that this is like the basic building block, but we'll keep scaling them up and using them for repetition. All right, any other questions with the conditional logic? Okay. Next step is iteration. And I actually showed you a little bit of iteration yesterday when I ran that dot map to say that all my cats' names were the coolest. So loops can execute a block of code a number of times as long as the condition is true. The block of code will continue to execute when the condition becomes false. The code after the end of the loop will be executed. So there's multiple formats for loops. Different loops can be used for different situations where maybe like a while loop is better in certain situations where a for loop is better in others. And there's also a lot of crossover between them where you basically it's just preference or stylistic guidance as far as what type of loop you actually use. So a while loop will run while the run condition is true, right? So if we come in here and we say let a equal 0, and while a is less than 100, execute the code in here. So console.log, a is a, and then we say a plus equals 1. That means that what happens in here is, and well, here, I'll just show you. All right, so if I say, oops. All right, so when I run this, there we go, right? And again, it did it 100 times. The computers start at 0, and so the 100th time was 99, right? And we can do, and so this is also something, so this is the plus equals operator. So what that is doing is a is 0, and instead of, if we just did this, we would never stop, right? Like a is 1, and I've just created an infinite loop, and it's just going to go until the computer runs out of memory and it crashes. And because it's basically, it's coming in here, it says a is 0, and then while a is less than 100, console.log a, and then the number, and then I'm saying a is 1. And it comes back, it doesn't come back up here. It comes back to the start of the loop and it says, what is a? Well, a is 1. Do it again. A is 1. Do it again. When we do a plus equals or a minus equals, what that is saying is whatever a is, add this number to it. So now when I have this, I say a is 0, a is 0. Okay, less than 100. Let's do this. Let's go ahead and add 1. So 0 plus equals 1. So a is now 1. A is 1, less than 100. Fire it off. Come down here. A is 1. Let's add another 1 to it. Now a is 2. We come up here. A is 2, right? And we're going to keep evaluating until we basically hit that a is 100. And then once that is no longer true, we don't come inside the loop anymore. We move on, right? And so same thing, like I'm console.logging here every single time that we go through the loop. Once we exit the loop, we'll continue to run additional code after the loop, right? So basically we never reach this until we break out of the loop. So we did this 100 times, then we move to the next line of the code outside of the loop. All right, so this is one way to do this. All right, the other way, and probably the more common way is you're a beginner, is going to be the for loop. And so instead of starting off with a for, we're going to do, or a while, we're going to start off with a for. And what it does is it kind of internalizes everything into the same line. Notice I had to put a up here, then I say while a, and then I have to add, increment a up here. So adding one at a time is incrementing, subtracting is decrementing. So I'm going to say let this is very common in loops. So I is iterator. And it's one of the few times where writing a single letter variable is okay. And what'll happen is we get into more complex problems. We'll actually do what are called nested loops, where we write loops inside of loops. And so you'll see a lot of for loops with I, and then a loop inside of it that says for J, and then for K, if you need a triplet nested loop for whatever reason. And we're going to say I equals 0. Semicolon, and we're going to say while I is less than 100, semicolon, I plus plus. So plus plus means increment by 1, minus minus is decrement by 1. And we're just counting by 1 for right now, but I could say I plus 3 or whatever other number that I want to do here for my loop. But we'll do plus plus for right now, right? And same thing, console.log. A is, oops, sorry, I was going to say A. I is what I'm using inside this one, right? And if I run this, there's my same loop, right? And so I can say console.log end of my for loop. Right, and same thing. So let's say if I don't want to do every number and I just want to count by 2s. Whoops. All right, so now basically I'm counting only even numbers. All right, and so I mean you can increment and decrement by any value that you'd like to. Right, and this typically you will see for loops. This is, we'll just call this a incrementing for loop, right? If I want to count backwards, all right, so I could do for let I equal 100, and we'll say I greater than 0. I minus minus. Oops.
Can you scroll down?
Yep, sorry, one sec here. Is that a little better? And we can say console.log. Oh, and I said A is up here. It's I. Right, so now we started counting at 100 and we counted down to 1. Right, and I could say less than or equal to 0, and now I'm inclusive of it, and there's my 0. All right, so this would be right, so loops can count up, they can count down, they can count by 3s. I could multiply in here if I wanted to, however you want to do it. Also, what would be very common, and well, one of the prime reasons for writing for loops is, so let's go back to this again. So let's say let names right. How many elements do I have in my array?
You got 5.
Okay, and what is the index of Charles?
0.
All right, and the index of Nugget?
4.
4, correct. So 5 elements, computers start counting at 0. Right, so I've got 0, 1, 2, 3, and 4. And I can say, what's the length of this? Names.length. Let's log those out. Right, so the length of this is 5. And if I want to just see one name in here, right, we can use box notation. So if I console.log this, let's see, I got my friends in the wrong spot. Right, this should only tell me Charles. And now if I want to do something, so like yesterday I showed you a dot map, which was kind of looking ahead. More frequently we'd see it in a for loop. So if I say for let I equal 0, and I say while I is less than names.length, right? And so this resolves to 5. And it also happens to be the exact length. So I will stop every time, even if I add more names, subtract names. I don't have to put a hard, like if I just put less than 5 in here, it would work. But if I take a name or add a name that I'm not going to get everyone in the array, this one will move dynamically, because right now length is 5. If I go here and I say Reese, right? Whoops, sorry, because I haven't done anything with this yet. Now it automatically moves to 6, right? So this changes. So as my array gets larger and smaller, by using names.length, if I want to do something to every name in here, this will automatically move with it. And so if I were to do just less than 6, this is called hard coding a value, right? And we want to avoid this as much as possible, because every time I change something up here, I then have to change it down here. So I have to change it in 2 different places. Right, and so now we could say console.log name is a cat. And so basically, if I just do names, what I'm doing is names is this entire array, right? So it's just giving me everyone, and then tagging is a cat on there. So if I want to just get the first one, I need 0, right? If I want the second one, I need 1. What do we have that we are using to count by 1 in here?
The plus plus, the I plus plus is counting by 1, and
Yep.
then you would put it you would box the 1 right where you're at right there.
Yep. So same thing. So if I hard code a value of 0 in here, what's going to happen is I'm going to count for my until 6. Charles is a cat, right? Because each time it comes through and it's saying, okay, name 0. Now, because the first time through I is 0, the second time through I is 1, the third time through I is 2, and so on. When I do it this way, we get that, right? And now I'm actually iterating through my array. So, and now to kind of wrap in like the conditional logic, we can say if, let's see here, names I is triple equal to Charles, console.log, Charles is not cat. So we're hard coding a value here just for like a simple example. Right, and so now what's going to happen is if we hit Charles in here, which it should on the first pass through, instead of just saying Charles is a cat and then moving on saying Todd is a cat, PD is a cat, we're going to do Charles is not a cat. Right, so Charles is not a cat. Every other time it comes through, it's false. We hit the else chain and we do this, right? And I don't have to put Charles down here because let's say I could also do, my wife's name is Jenna, and we do if Charles or right? So we got Charles as a human, Jenna is a human. And basically, so we know that that names I, it doesn't matter. And if I take Charles and I move them from the 0 index to the second index, because we're counting and we're incrementing through each one, we're going to catch up to it eventually. It doesn't have to be in a specific place. It's whenever we meet that condition, we'll take the true branch, else we take the false branch. All right, so that is some basics on the while and the for loops. There are other kinds of loops. So remember yesterday we talked about objects, right? Where we have a key value pair. So we can say a for in loop for objects, which is basically if we want to take an object and spit out each key's value. So if we come in here and we say, let's comment this out. All right, and so there's basically 3 key value pairs in here. And so if I come over here and look at that, so there's my object 1, and I say for let key in object 1. So I'd say for let key in human, right? And the iteration starts. Right, so there's first name, last name, age, those are the keys. Right, and same thing if I take human and I box through it to the key. Whoops, spelling error. Right, there are my values. So I could say right, and so and that's how I would get all the information out of an object. And same thing, I mean, this is like a basic data set. So we could do something like this where like what would be common is you wouldn't just see the one, we would see something like this where there's two different representations, and we could say right, and so then we need to write a for loop to iterate through each element in the array. And then if we wanted to spit out everything inside each of these, we would have a basically that's like an instance where we would use a nested loop. Let's see here. So the for of, so like this is an example of an array. So for let item of array one, iteration start. So if I do this, right, this is just going to show me the whole object, right? So now if I wanted to actually see each item for each human, right, so I can put this in here and I'm going to do right, so because this is my array of humans and this is human one and this is human two, but human one is an item, human two is an item inside array of humans. So then I come in, basically now I want to look at the key inside each item. So now when I do this, there's all the information all at the same level. So, and again, that like nested arrays, digging into data objects is one of the core concepts of what you do as a software developer all day long. That also being said, this is like day two. So if this is a little bit confusing, that's perfectly fine. The nested loops is a little bit more of an advanced concept. So like if I'm talking and it sounds like, if I sound like the teacher from Charlie Brown, don't worry about it. It will start to sound better, even by the, like, what I tell people is that if you make it to the third week of this, just looking back at the stuff that you were struggling with back on the first week, you'll be amazed at how much progress you'll have made. And it's like that constantly. You end up going to a coding boot camp. By the time you graduate that coding boot camp, you're going to look back at this, or like the first day of class, and you're going to just be like, I can't believe I ever struggled with any of this. It just seems so easy now. So let's see here. So how do you highlight multiple lines of text and simultaneously comment them out? You basically, just like you would highlight text with anything else, like you can drag it with your mouse, or you hold down the shift key. And if you're going from side to side, if you hold down control while you're holding down shift, you grab whole chunks. And then if you're on a Windows computer, you should, I believe it's going to be control /. And if you're on a Mac, it is command /. And that gives you the shortcut to basically the double slash at the beginning of the line. All right. So let's see here. Built-in methods. And any other questions about loops that we want to talk about before we move into built-in methods? Okay. Built-in methods. So there are common actions that we perform on specific data types, and most languages have built-in methods or functions that allow us to perform these actions. Right. So this is a string. So Illinois is a string. JavaScript has 2 uppercase. They also have 2 lowercase. And what will happen is when you do this, you will basically, you're taking Illinois, you're assigning it to a new variable, and you're running 2 uppercase on it. That new variable will, everything in there in the string will be uppercase. We talked a little bit about push, pop, shift, and unshift yesterday with arrays, right? So it's common to add and delete items from arrays. And so we can use this to manipulate arrays, add something onto the end of it. And we even talked about this a little bit earlier. Someone threw out the 2 fixed. And so that takes this 3.1666 off into the distance and fixes it to 3.17. Common built-in methods: strings, numbers, arrays, and objects. These are what are called prototypes. When we talked about the different data types, and you may have picked up on it when we looked at MDN.map. So you see this like, oops, map is a map. I want map GS, right? So we see like array prototype .at .concat, right? All these different ones. You see this prototype, and that threw me for a really hard loop when I was first reading documents. And it's basically just saying that this is like, this will only work on an array, right? And it's very easy to get these crossed over in the very beginning, because not every built-in method works on every data type, but some of them do carry over, right? And so like if we look at all right, so these are all the different string built-in methods, and you can see there's a ton of them, right? And so we've got a dot includes over here. If we look at over an array, we've got a dot includes. So it doesn't matter if you're doing this on a string or an array, they both have dot includes. Let's see here, array has for each, but you'll notice like string doesn't have for each. So in the beginning, it becomes very common, like, oh man, like I want to map, or like I want to iterate through my string, like a letter at a time. And we'll type in a dot map or a dot for each, and then it doesn't work, right? So if I say right? So we'll say, what did we have up here? Got names. So if I say names dot map name console dot log name. All right, when I do this, there's my list of names that are coming out of there. And if I say let cat equal Todd, and I say cat dot map cat dot log cat, right? Cat dot map is not a function. So that's, again, like if we read the error message, it's telling me that this does not exist as a built-in function on cat. Well, what is cat? Cat is a string. So there is no string dot prototype dot map, right? But when we did it on the array, you don't usually cross over very often between string and array, but I'll tell you, it's very tricky to keep them straight without looking back at the documents between array and object, because those both hold multiple pieces of data inside them. And it's very easy to say, oh, I want to do this one thing and I want to try and do it to an object, but that only works on an array. All right. And as I pointed out, like you can see there's tons of built-ins for each class or for each type. And I have not used all of them. Like I don't know what dot small does. So it does deprecated feature, don't use dot small. So, and I'm guessing like this deprecated, we see the trash can next to it. Right, from code point, I've never used that. And it looks like that has something to do with HTML error handling. So like you won't use all those, but like index of, like you can use in a string, right? So what this does is we've got the standard, the quick brown fox jumps over the lazy dog. And so the search term is dog, paragraph is the string, index of search term, so dog. And basically it's going to come back and tell us exactly where dog falls in here. All right. So anything on built-in methods, and you'll get to use plenty of them throughout the rest of the class as well. Okay, so problem solving, how to think like a programmer. Understand what the problem is asking you to do, how many inputs are required, what data types, what's the expected output, what data type. And so we're going to talk about this a lot as we start to do the challenges. We're going to start talking about how many parameters there are, what are the data types of the parameters, what is the expected output, what is the data type of the expected output. And we want to try and know those things before we start writing any code, so that it gives us a clear goal to move towards. Give examples of inputs and expected output. Do I need any other variables? Break down the problem into smaller problems. I mentioned this yesterday as well. If you look at a problem and you don't understand it, start breaking it into more manageable pieces and try and understand small parts of it. It's the same thing like when you're looking at putting together a table puzzle. And when all the pieces are scattered around, it's hard to understand where each piece goes. But as we like start to put in like the outline of the edge pieces, those are easily identifiable. And we get the corners, we start to build it out, and then we can use the surrounding pieces that we figured out to help us piece together the rest of the puzzle. Run your code often. So again, notice how like when I was changing from cheese sandwich to addition, I didn't just change a bunch of things at once. I basically changed something, ran it, saw what the new issue was, changed it again. You should be running your code as frequently as possible, because if you write 5 lines of code and something is wrong, you don't know which one of those 5 lines was the one that you didn't understand, right? So we try and get that first building block. Like notice how I didn't just like write a loop and put conditional logic in it right away, right? Like I wrote a loop, showed what the loop was, understood that my loop was working. Now I start to add my conditional logic. Okay, well, I've got the first case of my conditional logic. Now I'll add the next part of my conditional logic. Okay, well, now I'll add an else if statement into it to make it more complicated. Okay, well, now I'll add a and operator into my if case to make it slightly more complicated. So you shouldn't worry about writing the perfect solution the first time you write something, right? Like this is going to be incremental. You want to write, it's more important that you write something that you understand and that you can build upon than trying to solve it as fast as possible. Debugging, a very important skill. Read and understand the traceback errors. The traceback errors are the errors that we get in the console message. And so much, and like I said, at the level that we're writing code at here, these almost 100% of the time are going to tell you exactly what's going wrong. So, and then lastly, Google, right? I got asked how many characters a function name can be. I don't know. We're going to Google it, right? I said this yesterday as well. I don't know the answer to everything. It's impossible to know the answer to everything. And I will get things wrong. I will return statements and wonder why it's not printing to the console sometimes, just because there's so many different things to keep straight. And I mean, I've already been writing code for like 9.5 hours already today, right? So it's like you're gonna make little mistakes. All right, so that's it for session 1. Session 2, like I said, is pretty short. We're just gonna, we don't really need to talk too much about REPL, and then we're gonna talk about code formatting. In fact, we'll just push through it. Is there anyone in class that has not been able to get a Replit account opened up? Okay, so it sounds like everyone's got Replit up and running. Outstanding. Basically, we're going to go into the challenges. I'll show you the list of challenges. Everyone should have the list of challenges. I can send it out again or Slack it to anyone that doesn't have it. It's in the intro to coding. It's been in the email, but we'll get it for you. You'll click on the link. It'll take you to Replit. Like the base answer, we're going to make a copy of it called forking it, so that you have a copy of the Replit for you to keep forever. And then you can start editing the code from there. That's pretty much all we need to know about Replit. I've already covered the basics of writing a comment, and we'll go over this again. You see how it tries to help us out with the color coding. Console.log sends it over there, and we want to read the error messages. Formatting and clean code. Your code is going to be messy in the beginning, but we want to try and make it as clean as possible. We want to get into good habits. Again, I kind of showed you the other day that Replit isn't necessarily doing you any favors. Like I use VS Code all day long. Every time I save my file or paste or navigate to a different file, my code will auto format and it helps clean up my code for me. But you'll also notice that, just through like force of habit, like when I miss a space or like I do something and something's not lined up right, like I'm going back and cleaning up my code. It's a good habit to get into. So proper formatting of code, if you remember anything, just be consistent, right? So, it's better to have spaces between your variables and your operators. But if you don't put them in there, just make sure that it all kind of looks the same, because it gets even more difficult to read when you change it based on line. But again, space is free. We don't charge extra for it. So there's like making it easy. Like the computer doesn't care. Computer doesn't care if there's spaces or no spaces. I could smash all of this stuff into a big block of code. The computer is going to read it. But if I did that, I would make it harder on you. I'd make it harder on anyone else that needs to read my code in the future. So the name of the variable should make it clear what the data represents. We talked about that. use Camel Case when naming variables. This is Camel Case. I didn't mention that, but that's what it is. So this basically JavaScript operates in Camel Case. And so like when I said array of humans or shoe size, so let Camel Case. And so first letter is lowercase, and then every word in there after that is going to start with uppercase. Right. And it doesn't seem like much, but it's a lot easier to read that than it is to read that. Right. And so because this all just kind of runs together. There's pretty much everything is Camel Case in Python. There will be case, which is basically where you get proper capitalization when you're naming or class case when you're doing classes. There's things called constants, which will be all uppercase, snake case, or what. So Python uses what's called kebab case. So right, and so different languages will do it the same way, but this is a variable in JavaScript. This is a variable in Python. And so, and then my favorite one is when you have to do this. Right, so I'm sorry, I called this kebab case. This is snake case. And this is screaming snake case. And kebab case gets used in some supporting languages, and that's basically like that, where it looks like the variables on a shish kebab. All right, and that is it for session 2. So like I said, wasn't too worried about carrying over into this session with session 1. That's a lot of talking. So what we're going to do now is 7:36 Central Time. I'm going to pause recording. We're going to take about a 10-minute break. I will see everyone at 7:45 Central Time. If anyone's got any questions, I'm happy to answer them now, but other than that, we can start a break, and then when we get back, we'll start on the challenges. All right. Yeah, so Chad, I was just asking if you have a copy of the list that we're looking at right now on my screen, the Code Platoon Bootcamp Prep challenges. Cool. Again, if anyone doesn't have it, please let me know. From here going forward, each night, there'll be a lot less of me going through slides, and we're going to be going through challenges. As I outlined yesterday, what I'll try and do is do a challenge or two by myself, show you how it's done, walk you through it, kind of prompt some learning, and then probably these first couple, I may split us out into very small teams, just like groups of 2 or individual work, and we'll come back, we'll go over it together. And then as we start to get to some of the more complex ones, then we'll start going through. I didn't quite catch the attendance tonight, but I think we're in the high 30s or so, where we start breaking out into like teams of 4 or 5 to work on some of the tougher challenges, but that won't be tonight. So what we're going to do is we'll look at this very first one. Should be a pretty easy challenge from what we've already discussed. So we're going to click on it. We're going to open it up. And so we're going to see a screen that looks like this, where it says first name, last name. And then we see that this replit belongs to CP admin, Code Platoon admin. We see that 936 people have forked this before. So I'm going to fork it. Right. And I'll probably have a number on mine because I've forked it multiple times before. Right. So first name, last name, 2. So this is probably like the 3rd time that I've forked this. All right. So when we come in here, we have a README, and the index.js. Not all of these challenges will have tests written, but some of them will. So the README says, write a function that takes your first name and your last name as arguments and returns your first and last name as a single string. All right, so let's start to break this apart systemically. All right, so first question is, how many parameters am I working with here?
2.
Right, 2. And what type of parameters are these?
Strings.
Yep, they're both going to be strings. And if you ever see params, that's shorthand for parameters, very common. Right? What is my expected output?
A string.
Yep. Right, so I've got a string that's my first name and a string that's my last name. And it says right here, please output these as a single string. So, and we've kind of been using this as an example throughout, right? So we're going to do return. Right, we get true, true, true. So now I talked about this yesterday, right? So if I do right, I see the names pop up over here, but notice how I'm failing my tests, right? Because nothing is coming out. I'm not returning anything. So we're saying, is full name Michael Jordan equal to Michael Jordan? Well, this is basically resolving when I don't have a return statement, automatically resolves to undefined. And that's going to show us false. All right, and I can do both. Right, but this isn't necessary to get the correct answer. Right, and same thing I can do. Right, and I still get true. So both of these do the same thing. It's just a slightly different way to accomplish the same goal. Any questions about what we did here on this one? This was a pretty basic one. So the first couple are pretty basic.
Can you touch on the like $sign curly braces and how that differs from, I guess, more of the long form with the 2 additions and the extra space? Can you touch on how those correlate?
Yeah. So this is string concatenation, right? So that's where we're adding strings together. And so this is one way to do it. And this is the other way to do it. This is basically when you put it in backticks and it looks all the same color, but notice how basically this, so like when I do a string, notice how all of the text is this gold color, right? So this is still a string and it's gold, but when we do the $sign in the curly braces, once we do that, anything in here does not get treated as a string, it gets treated as a variable, right? And so what we're doing here is saying, in line, just tell me whatever is in here and basically make it a string and plug it into my string. All right, so this is all false because it's not coming out exactly that anymore. So if I take this and turn this to a console.log, right? So we see that it's first, and then first name first, so the first time is Michael, and the second time, and the last name is Jordan. So this is saying first Michael, last Jordan. Right, so it just allows us to plug variables in. I think when I did my notes, right? So when I did this up here, right? So when I said names I'm looping through in this for loop, and whatever name is in here is basically getting added into this string and then logged to the console. Right. Oh, so cat.map is line 69. Right, so Charles is a human, Todd is a cat, PD is a cat, right? So this is the variable. And so I could take this out, right? And I don't have to wrap it. And I could say names I plus is a human, right? And I still get the exact same thing there. It's just two different ways to do the same thing. And then, like I said, I encourage everyone to make their own forks. You'll work on this, but I will, at the end of each night, I will pass off all of my solutions so that you can access them in the intro to coding and reference the solutions that way. Yes, the box means that we're looking into an array. So the square brackets, right? So this was the iterator I. So the first time through, this is saying I0. The second time through, we're saying I++. So I is 1, I is 2, I is 3, I is 4, I is 5. Right. And so by leaving it, this is a hard-coded value. This is a dynamic value. And we typically want our values to be dynamic so that we don't have to write the code a bunch of different ways, right? Like we just have to write the loop and we're going to iterate through that array of names without having to write a new line of code to treat each name differently.
I have a question.
Yes.
The first test, was it supposed to return a string or just true? I'm kind of confused.
I'm sorry, could you say that again?
The first test, was it supposed to return a string or just true?
Just true.
Okay.
Right? So this is a string. This is a function that resolves to a string. But as soon as we add a comparison operator, this whole thing is going to return true or false. All right, so from here is one condition. This is the other condition. So like, let me go ahead and comment that out. This doesn't need to be here. We'll turn this back on. So now we have 3 tests that are passing. This is all true. So if we look at this just by itself, right? So if I say, I know it's a little harder to read when it's commented out. I'll comment it out afterwards. So the first pass through, what's going to happen is we're going to run through the code. We're going to get down here. We're going to say, okay, whatever is in between this parenthesis and this parenthesis, I'm going to spit out to the console. Right? So we get here, we say full name. Well, I've got a parameter of Michael and a parameter of Jordan. I call full name. I put Michael and Jordan right here. right? So now this turns to full name, Michael and Jordan. Same thing right here. Right, that turns into this. And then down here, this turns into right. And so now what's happening is like the next operation that the computer does, it says, is Michael Jordan strictly equal to Michael Jordan? And it is. So this turns into this, right? And then this gets sent to the console. So that's what's happening in 3 steps here. Does that help kind of see what the computer is doing?
Yep. Thank you.
Yep, no problem. Any other questions from anyone else on this one?
I've got a question on this.
Yes.
Man, I must have just not read the question. Are we supposed to take our first and last name in an argument and then return it as a single string? Is that how it's supposed to be? Because
No, so you're right, except for that it needing to be your name. So remember, when we write a function, it is reusable. So that is used to take anyone's first name and anyone's last name and combine it into their full name, right? So we're going to write a function and it says your first name and your last name as arguments. So that is a little misleading and returns your first and last name as a single string. It should just be a first name or a last name. But so these right down here are called tests, right? So this test will pass if you do this function right. And so it will do it. So like we can say console.log full name right, just like that. And we're not doing a comparison at this point. So it will return your name as a full name. But again, once we add an operator in here, right, we get a true. And same thing, like if I just change the spelling of your first name, now we get the false. And so it will do your first and last name, but the tests were written a couple of years ago and so written by Tom. And so he just used some stock names in here. Right. But be it your name or any of these test names, it should do the same thing each time.
so what it should have done is come up and said true, if it was indeed true, right?
Yes.
And so all that you had to do is just set up the return. You didn't even need to do the function because it was already set up in the bottom, right? Or am I wrong?
Right. So when we came in, function full name, last name was already written for us.
Right.
And all we had to do was put basically the guts of the function in.
Okay. I went a couple of steps further because it wasn't shooting out my name. So I thought, oh man, I'm going to crap this. So
No,
I thought, the first one I'm going to tank. It's like, yeah, okay, I'm going to go to code Platoon.
No, you're good. That's a good question. But yeah, I mean, poorly worded for a first challenge. That's why I'm here. But past that, it does bring up the important concept that like I should be able to take anyone's name in this class, their first name and their last name, and write a test, and this function will work over and over again, as long as you're giving it 2 names. And then the function itself is just this. Right?
Right,
And
right.
all of this, like from here to here, from like the console.log to here is just for the test setup. And that's what gives us the true, and console.log's the true to the console.
Gotcha. Gotcha. Well, yeah, I'm excellent. Thank you so much.
Yep. All right, so if I do this, right, so this is just testing overhead, right? The actual function is right here. All right, so any other questions on this one? All right, cool. So first function in the books, everyone, or first challenge in the books. So let's go ahead and take a look at the next one together as well. All right, so write a function that takes in the amount paid and the total cost is integers and returns the total amount due in change, right? So the amount paid, the total cost, and what our change is. And it looks like we can take some floating values in here. Again, dealing with money, but dealing with it at a pretty basic level here. There's no multiplication, it's just subtraction. So we don't need to do anything crazy with it. All right, so how many parameters?
2.
Yep, 2 parameters. How many output, or I'm sorry, what are the parameters?
They're numbers.
Yep, so integers, which is computer talk for numbers. And what type is the output?
Integers.
Yep. All right, so the last one was addition. This one is just basically subtraction. So we can say return. And notice how I'm getting these pop-up boxes that, like, as I start to type, they're giving me the different things that I can access. So it's telling me this is a function, this is a parameter, and I can use that to autocomplete what I've got going on.
You have a spelling error.
Yep, because I cannot run anything. And notice, so when I had this, right? So this is white, and then I'm getting a red line here underneath this. And so my guess is that that should be populating, but Replit seems to be having a rough day, but it's telling me that something is going on. So when I correct the spelling error, this turns back to blue, and that red line goes away. All right, so we get true and false. All right, so when we have this, so we get 10, 728, and 272. So now I'm trying to remember, don't change the test. So if we take a look at console.log, total change, 10 and 728. Right? So remember how I said that we'll get into like some crazy rounding stuff here, and I said, oh, don't worry about it, this is just simple subtraction, and here we are staring down some crazy like rounding error. That's because computers don't deal with floats very well. And what gets worse is, so if we say, right, so then we JavaScript float subtract, JavaScript plus and minus crisis. Why is this happening to me? Exact change exercise. Why is the floating point error? Best solutions. What every JavaScript developer should know about floating points, right? And so this is not the first time that this issue has happened, right? And so, I mean, this article looks like it's written at a pretty deep level. We're getting into memory allocation here. We don't need to read that. But we can take a look here on Stack Overflow. Right, so I get the result of this. Like this looks something similar to what we're doing. No, nothing's wrong with your code. Most decimal fractions cannot be represented exactly in binary use. Number, two fixed, x, where x is the number of decimals, you want the number. So if we do that, and if I'm trying to remember correctly, I think two fixed will fix this, but I'm not 100% sure. So we could say, right now we're at 271.99. So I can wrap this whole thing and do two fixed, and we'll say two places. Right, so now I've got a false false, right? But now see how I've still got 272 here and it's false. And what's happening now is if I run this again, and let's say I do 175, right? So now instead of just returning 25, I've basically pushed it out to here, right? And so we can continue to make this more complicated. Like there are other solutions that we can do here to fix. Let's see here. I can take, let's see. Trying to think how I would tackle this. Yeah, it'd probably be an if statement, and I would do something like this. This still worries me though, that this is false. And that's where, again, if I do something like this, like it's not strict equality. Oops, I've got the if statement. Right, that's true. So it's saying this and this. And so, because what two fixed does is it displays it to the second decimal point, but it doesn't mean that it's not actually this number behind the scenes. And so to get it exactly like that, if I remember correctly, I don't know that you can with the way he set the test up, but to get the first one back, what I would probably do is an if statement that says, if I'd probably do, instead of returning this right away, I would just do the change equal amount paid, it's total cost. So let's go ahead and see console.log change. Right, so we've got that. Yeah, sorry, Mark, with the plus sign in front of it. Okay, so you got it off the Stack Overflow. Which answer did you use, Mark?
He had the two fixed two on the back end of it with the plus sign in front. So
the plus sign in front is what fixed it. And honestly say, I've never seen that before. True and true. So there you go. That is the solution. Mark, thank you. And like I said, I won't get all of these right because I don't deal with all of these concepts all the time, but I didn't know that adding a plus sign in front of it would be what does this. So I will, this is the link that Mark dropped in the chat. I will also add it into here so that we have it as a reference. All right, well, that makes two of us. So, all right, so
like, what is that operator actually doing before that? Like
the plus?
Yeah.
So Mark was saying that the Stack Overflow said that it converts it into a number. Yes, don't convert it into a number. So, so here's my problem. Here's something that makes it work. Here's someone saying, don't do that. Well, this is like my day all day long. Numerically, there is no such thing as 10.50. There is only 10.5. Only a string is capable of holding a value like 10.50, and you get a string from two fixed, but then convert it back to a number. So you don't have, so I couldn't have said it better than lose the plus signs. Well, so, okay, so two fixed is giving you a string and plus is sending it back to a number. Again, in the Stack Overflow is an interesting place. So, hey, I've got a problem. Hey, somebody gave me a solution. Hey, you shouldn't do that, but notice like the lack of an answer. So doesn't actually point you in the right direction. And so something like this, lose the plus signs and you should be fine. Function random generator. And so again, what they're missing here, and this works fine for this example because there's no equality operator in here, right? Like we're not trying to compare this to anything, because if we did these two numbers and tried to compare it to the same number with that two fixed in there, we would get the exact same error that we're running into. So, I mean, take everything kind of at face value when you're on Stack Overflow. You'll see people arguing on here about how their way is the best way to do it. At this point, for the second challenge, I would be pretty satisfied with this as a solution. All right. Any other questions about this one?
I have a question, not really, I guess, related to this one, but just in general. To do order of operations, say for if this is more complicated and you needed to group amount paid and total cost together, would you use parentheses, or how do you do order of operations
Yeah,
for a
so
formula?
or order operations is left to right. You can use parentheses to basically things inside parentheses get done first. Right. And so all right, so we end up right back here at the Mozilla MDM docs, operator precedence, right? And so we've got a big long article here on what to do. And so not only mathematically, but like it's giving us a comparison order of operations, what's going to happen with this, right to left, left to right. And so I will take this and I will drop this in here as well. So we'll have that link there as well. Any other questions? Okay, so let's go ahead and take a look here. Convert to hours. So we're going to write a function that takes in a number of minutes and returns the hours equivalent as a float integer, right? So basically, if it's less than an hour, we'd expect it to be a decimal. And it looks like they've got that. There are no tests written for this one. Like I said, not all of them. But it doesn't specifically look like we're cutting it off at any specific one. So what I can do with this is I will let you guys solve this one. It's 8:26. What I'll do is for this first one, I'll just let everyone take a crack at it on their own. I'm going to give everyone until we'll say 8:40, and we'll get back together and we'll go over the solution together. Are there any questions before I kind of turn everyone to working on it on their own? Okay, so go ahead and try this one on your own. 8:40, we'll come back and I will work through the solution. We'll go over it together. And we'll probably have one more challenge after that we'll go over together. All right, everyone. Let's see here. All right, does anyone want to go over the solution with me? Okay.
Yeah, so I did return minutes, divide by 60, and then console log 2 hours 45, 2 hours 75, and then 2 hours 125.
Okay, so let's see here. So, but before that, so how many inputs do we have?
One.
All right, so we've got one input. What's the input type?
Integer.
Integer.
Yep. And what's our expected output type?
Integer.
An integer, which will be also a float. Okay, so so you had done the, can you say that again?
Yeah, so return minutes, divide by 60. And then console log 2 hours. Started with 45, but 125 works. And then 75.
All right, so we've got 75, 1.25, and then that 2.0833 with the rounding. So I'm seeing some other things out here. So we've got the parse float with the hours fixed to 3. We've also got the, looks like we did it with 2 fixed 2. So like if we take the whole thing, round in here, so 2 fixed 2. Oh, why are you angry at me? There we go. So
Wouldn't it be 2 fixed 3 because the markdown shows 2.083?
yep. And so, but what happens is like when we do the 2 fixed 3, like we get the extra trailing 0 over here. Michelle, did your solution basically take care of the extra trailing zeros?
Yes.
Okay, so if we do throw a parse float in here and add the 2 fixed 3, looks like we still get the trailing zeros. Did I miss something from your solution?
I did a let hours and then added a return parse float hours and put the 2 fixed inside of it. So I
Okay.
declared
Oh,
a new variable.
So I think what we can do is this then. There we go. So, and that gets us to where we were looking. So again, when we're working through these, it's perfectly fine to get partial solutions, the full solution, to work towards something iterative, right? Like we got this, so we got the minutes divided by 60, that got us a step closer. Hey, we need to use the 2 fixed, that got us a step closer. Hey, we need to wrap the whole thing in parse float. And that basically got us even close. It basically got us to where we were at with our solution. So nice job for everyone on that one. So any questions on what we did with this? And again, if you don't understand it, it's fine. Like I said, this won't be the last time we see stuff like this. Like it won't be the last time we see two fixed. It won't be the last time we see parse flow. Right. And so, and Michelle, like looking at her solution, she like I did mine in place. She had said she did a separate variable. So like we could say let hour equal minutes divided by 60. And then what we do is we take this out of here and we just put hour right there, right? And we get the same answer. So this may be slightly more readable than the way I had done it. Like there's less all in one line. We just see hour to fixed. We look up here, see what hour is, and we know that we're going to parse the entire thing as a float. All right. And next, will be a mortgage payment. Oh boy. All right, so instructions: write a function that calculates the dollar amount returned on your initial investment, given an initial investment and annual return percentage. All right, so if we invest 100,000 at 5%, we get a $5,000 return. If we invest 15,000 at 0.85%, we get basically $1,275. Right. So again, looking at this, how many params?
Two parameters.
Yeah, two parameters. And what are my param types?
Integers.
And what is my output? Also an integer.
Spelling error.
Yeah, so again, we look at something like this where return, and we can do this iteratively again. Just grab both of these. And this time it looks like we're going to do some multiplication, right? So take this. There's our 5,000, there's our 1,275. They gave us some big, nice big numbers to work with, so we didn't have to worry about any decimal places on this one. So we would, I mean, we're good with that. Like if we knew that we'd have smaller amounts, then like the next step, we could start to look at plugging in. Like if the requirement said like, hey, always take this out to the second decimal place, right? Or cut it off at the rounding number. Like then we could start to add in like the two fixed and the parse flow, and we could make this more robust. So it is 8:50. Let's see here. What is? So the last one here is convert to hours and minutes, which is building on the kind of the one that we just did, right? And so it looks like with this one, we're going to take a number of minutes and we're going to return it out to a string that gives us the number of hours and the number of minutes. So what I would say with this one is we've got about 10 minutes left for the night. I'm not going to go over the solution for this one tonight. Feel free to look at this one. I will cover this one first thing tomorrow, even before the lecture. We'll go over it, but you can poke at it tonight if you don't have time, or if your brain is at maximum capacity, that's perfectly fine. But if you want something to think about or poke at tonight or play around with, it's all yours. And we'll go over the solution tomorrow at the beginning of class. Were there any other questions that I could answer about any of the stuff that we did tonight, or just stuff that originally popped into your, or that has popped into your head throughout the evening that I can answer for you? Yes, sorry. When I say tomorrow, I completely meant Thursday. Do not come here tomorrow. I will not be here. Well, I'll be sitting at my desk probably, but I won't be online. And I'll even further clarify that. If you've got issues, drop it in the intro to the coding. You can always Slack me directly. You can email me. I'm pretty responsive to Slack. I don't have the opportunity to check my email constantly because I've got so many different email inboxes that I have to monitor for my job. It's like I'm in a chain of contractors, so I've got my company email, the other company that I subcontracted to's email, that a third contractor's email, and then I've got army.mil email, and then I've got a code platoon email, and I get stuff in all 5 of them throughout the day. So if you want to get a hold of me, Slack me. I see the little red numbers pop up. I'm generally pretty quick to respond to those. If there aren't any questions directly related to class, I'm going to stop recording. I'm going, again, more than happy to answer any questions that you have, even once I'm done recording, and I'll stay online as long as people have questions for me.